Professor in Civil Department working Emmanuel Research JJ College of Engineering, Natala. Today I am going to discuss about Bernoulli's equation. Bernoulli's equation introduction. Bernoulli's equation is a fundamental principle in fluid dynamics that expresses the conservation of energy for a moving fluid. It states that steady, incompressible and inviscous flow, the sum of the pressure energy, kinetic energy and potential energy per unit volume is constant along a streamline. For a Bernoulli's equation, we can written P plus half into rho v square plus rho gh equal to constants, where P is the pressure, rho is density, v equal to velocity, g is acceleration due to gravity, is constant value is 9.81, height is height. Bernoulli's equation derivation. Consider a pipe with a varying diameter and height through incompressible fluid is flowing. The relation between the area of cross section A, flow speed B, height from the ground Y and pressure P at two differential points 1 and 2 are given. We can diagram Bernoulli's equation, two cross section, force equal to F1 equal to PA, where is P is pressure, A is cross section. Therefore, force equal to pressure into area. The work done on the fluid is given as dW equal to F1 dH1 minus F2 dH2. We can written force equal to pressure into area. Therefore, dW equal to P1 A1 dH1 minus P2 A2 dH2. Therefore, we can written dW equal to P1 dV minus d2 P2 dV equal to P1 minus P2 the dV. We know that the work done on the fluid was due to the conservation of change in gravitation potential energy and in kinetic energy change. The change in kinetic energy of the fluid is dk equal to half into m square v square minus half into m1 v1 square. Therefore, we can written half into rho dv v2 square minus v1 square. The change in potential energy is given as du. Therefore, equal to du equal to m2 gy2 minus m1 gy1. We can written therefore du equal to rho dvg y2 minus y1. Therefore, the kinetic energy equation is given as work done equal to kinetic energy equal to potential plus potential energy. dW equal to dk plus du. Therefore, we can written P1 minus P2 dV equal to half into rho dV P2 minus P1 square plus rho dVg y2 minus y1. Therefore, P1 minus P2 equal to half into rho P2 square minus P1 square plus rho g y2 minus y1. Rearranging the above equation, we get the Bernoulli's equation P1 plus half into rho V1 square plus rho gh1 equal to P2 plus half into rho V2 square plus rho gh2. P1 plus half into rho V1 2 plus half rho gh1 equal to constant. The Bernoulli's equation equal to P1 plus half into rho V1 square plus rho gh1 equal to constant. Thank you. Have a nice day.